Hi guys, welcome back. In the next set of videos, we are going to be multiplying and dividing radical expressions. Today we will focus our energy on multiplying radical expressions. So let's do this. So as you can see, we have 5 problems to knock out and then we're free to go. So problem A, we have 7 times the square root of 2 multiplied by the square root of 54 minus the square root of 24. Okay, fantastic. So you are going to handle this however you like. My recommendation, first look at the grouping symbol, see if we have any like radicals to combine. So at a first glance, I want to go ahead and distribute the 7 root 2, but the biggest recommendation that I can give you is this. Simplify the radicals first and then work your magic. So square root of 54, you have ways to go about it, okay? The index is 2, so it would be nice if we can think of a perfect square factor. And if the numbers don't come to us, then we can write 54 as the product of prime factors. We've done it that way in other videos, so with your permission, I'm going to pretend like the perfect square numbers come to me. So a nice number that I can square root is 9. So we're going to rewrite square root of 54 as the square root of 9 times the square root of 6. I'm going to put a temporary pause on the square root of 24 because my game plan is to simplify this radical and then look at the world, okay? Square root of 9, where am I, simplifies to 3. And the square root of 6 cannot be simplified. So now let me go ahead work our magic to simplify the square root of 24. 24 has a perfect square factor, namely 4. So we're going to write this as square root of 4 times square root of 6. Okay, simplify whatever you can. The square root of 4 simplifies to 2. Let me go ahead, take a pause, and that's my visual break. The steps lined up, but when I'm adding or subtracting radicals, I tend not to focus on lining up the steps. I just go to attack mode, and then at the end, I line up. Okay, so let's bring down our problem. So we have 7 times the square root of 2, open parenthesis, times 3 times the square root of 6. The operation is minus 2 square root of 6. Fantastic. So in the beginning, square root of 54 and square root of 24 were not like radicals. They are like terms in the sense that they're numbers, so we can combine them with the use of a calculator. But they're not like radicals because they don't have the same radical part. But check it out. Thanks to our hard work, once we simplified each radical, we realized that the terms are actually like radicals, so we can combine them. So when we do, 3 minus 2 will leave us with 1. And then we tag along that radical part, okay? So after all that hard work, we will realize pretty much we're left with 7 root 2 times 1 root 6. Okay, let me take a pause because my phone, Google opened up. Okay, sorry about that. I was having a moment when Google Assistant opened up. I have no idea why. It's because the government is always listening. Okay, so let's do this. So we have 7 root 2 times 1 square root of 6. Let's multiply the integer factors together and then the radicals together. Product of 7 and 1 will give us 7, and the product of the radicals, namely root 2 and root 6, will give us square root of 12. Sorry, I sometimes I say root or square root. I interchange those two. Okay, so that is our answer, but the question is it simplified all the way? Can we simplify more? A square root of 12 can be simplified because it has a perfect square factor, namely 4. Okay, so we're going to rewrite the square root of 12 as the square root of 4 times the square root of 3, and then we handle it however we can. I know that you know that the square root of 4 simplifies to 2. And when we take our time, product of the integer factors, namely 7 and 2, will give us 14. And what's going on with that 14? It is being multiplied by the square root of 3. Cool. So after all that work, our answer boils down to 14 times the square root of 3. Okay, so that's our first problem. Let's go ahead and knock out the next one. Okay, there's no surprise. I showed you all the problems that we're going to do today. And whenever I have time to type them up, I think I'm going to type them up in the beginning so you know exactly what to expect. Okay, so problem B. So we have 4 plus square root of 21 times 4 minus square root of 21. I am at a crossroads. I think that's the saying. I am at a crossroads. I need to stop saying those words. Okay, I am at a crossroads in terms of how to multiply. my initial reaction is, look, we have conjugates, product of conjugates. Oh, multiplication shortcut, difference of squares. But what I notice is that sometimes I try to take a shortcut, but I don't do the shortcut correctly. So if I don't take the shortcut correctly, then it's not really a shortcut, okay? So for your protection, today we are not going to be taking any multiplication shortcuts. We're just going to FOIL it out or multiply however we can. And if you're really interested in taking a shortcut, then just see me, okay? So let's do this. We have 2 terms times 2 terms. Let's go ahead and FOIL out this bad boy. So product of the first terms, namely 4 and itself, will give us 16. Product of the outer terms, 4 times the square root of 21 will give us 4 times the square root of 21, but it's negative. Product of the inner terms, square root of 21 times 4 is just square root of 21 times 4, but we'll put the integer factor first. Last, product of the last terms, positive times negative is negative. Square root of 21 times square root of 21. I don't know what 21 times 21 is off the top of my head, so what am I going to do? I'm just going to use exponents for repeated factors. Okay, so minus square root of 21 squared. It's kind of like if it was x times x, we would just be like, oh, x squared. Okay, same difference. So let's take our time, simplify all the radicals, and then combine like radicals as needed. So if we have only one integer or rational number, let's bring it down. We have 2 terms that have the radical square root of 21. Oh, sorry, I crossed it out. Okay, so let's go ahead and combine them. The sum of negative 4 and 4 will give us 0. So in this case, the sum is actually cancels out. And then we have a minus sign. And then we have square of square root of 21. Well, check it out. Index is 2, power is 2. So pretty much the square and the square root undo each other. And that will leave us with the just with the radicand of 21. So this is our answer. Well, this is our solution. But notice that since I have too much space, it is very easy for me to make a careless mistake. So with your permission, let's go ahead and write it so everything is like touching itself. So everything is closer together. That's what I meant to say. Okay. So when we take our time, difference of 16 and 21 will give us negative 5. Okay, so it doesn't matter how you attack this problem, whether you went straight to FOIL or you took the multiplication shortcut by applying the difference of squares, we're all gonna get negative 5. Okay, so handle it however you can. Okay, so up next we have 11 plus the cube root of 7 times 11 minus cube root of 7. So once again, we have product of conjugates, copy opposites. So you can take the multiplication shortcut with difference of squares, or you know the drill. We're just going to FOIL everything out. Okay, so let's do this, and hopefully we don't, not we, because you're a pro. Hopefully I don't make an arithmetic mistake. Okay, so F, product of the first terms. Product of the first terms, namely 11 and itself, that will give us 121. Product of the outer terms, 11 times the radical is just 11 times the radical, but it will be a negative. Okay, 11 times the radical, or 11 times cube root of 7. Product of the inner terms, radical times 11 is just radical times 11. Okay, properly read as 11 times cube root of 7. Okay, last, product of the last terms, cube root of 7 times cube root of 7. Well, positive times negative is negative, and then it's up to you how you want to write this. You can either multiply the radicands now, or you can just use exponents for repeated factors. It's really a personal choice. I'm going to use exponents for repeated factors. Okay, so that will give us cube root of 7. But we got 2 of them, so we're going to use exponent of 2. Okay, let's go ahead, clean up our solution. So we have 121. Negative 11 cube root of 7, positive 11 cube root of 7. We have the same radical part, so they are like roots, or like radicals. Let's go ahead and combine them. Negative 11 plus 11 will give us 0, so the sum cancels out. Okay, then that will leave us with the negative sign. I would love to say the square and the exponent of 2 and the index of 3 cancel each other, but that's a lie. They have to be the same. So in this case, go ahead, bring in the exponent, and then square our radicand. Square of 7, or 7 squared, will give us 49, so that will give us cube root of 49. Okay, so now both of these terms are like terms because they're numbers. So with the calculator, we can combine them. But by hand or without technology, we can't combine them. So we're just going to write them side by side. So the answer is 121 minus cube root of 49. Fantastic. So today we are going to do 5 problems. That was our third problem. Let's go ahead do our fourth problem and then we're almost out. Okay, so fourth problem is square root of 13 minus 6. Let me pause it. Okay, and we're back. So problem D, we have square root of 13 minus 6. Remember, the power rule only holds true for individual factors, okay, whether it's a solo factor, product of factors, or quotient of factors. We can't distribute the exponent, okay, so no. Okay, so what are we going to do? You have options. You can take the multiplication shortcut and square the binomial, or you can just be like me and be like, we don't have time for multiplication shortcuts, so we're just going to do it however we want. In this case, since the exponent is 2, let's go ahead and write this expression without the exponent. Let's go ahead and write the 2 factors of square root of 13 minus 6. Okay, so that will leave us with square root of 13 minus 6. But we have 2 of them times square root of 13 minus 6. Okay, now that we have product of 2 binomials, let's go ahead FOIL this out, and it's really up to you how you write down the products. Depending on how you see these numbers, that's what you will write. Square root of 13 times square root of 13, you can multiply the radicands or you can use exponents for repeated factors. Depending on the mood that I'm in, that's what I'm going to do. With your permission, I'm just going to multiply the radicands. 13 times 13 will give us 169. So the product of the square roots will give us square root of 169. Product of the outer terms, square root of 13 times negative 6 will leave us with negative 6 times the square root of 13. Product of the inner terms, negative 6 times the square root of 13 will give us negative 6 times the square root of 13. Please don't change the signs, okay? Something that I wanted to point out, I wanted to say this, but I forgot. When students rewrite it without the exponents, sometimes they get nervous and they'll say, oh, minus 6 plus 6. But it's like, no, my friend, we have 2 factors of the base, so we're twins, okay? Please don't switch out the signs, okay? All right, so I lost my track. First, outer, inner. Okay, product of the last terms, namely negative 6 times itself, will give us 36. So that is our answer. Let's just see if we can simplify the expression more. Square root of 169. 169 is a perfect square, and the square root of 169 will simplify to 13. When we combine the like radicals, negative 6 minus 6 will give us negative 12. So that's minus 12, and then we tag along that radical part, and then we bring down the plus 36. Okay. All of these 3 terms are like terms because they're numbers. So with the calculator, yeah, we can combine all 3. But by hand, we can only combine rational numbers with rational numbers and irrationals with others. In English, regular numbers with others and then radicals with others. Okay, so let's go ahead combine the irrational numbers, the ones without the radical. 13 plus 36, who has a calculator? 39, 49. That will give us 49. And then we only have 1 term with the radical. Okay, so that is our answer. I'm going to box it and then say my piece. The worst thing you can do to yourself is nail it, meaning get the right answer, but then get dinged because you got a little bit nervous. One of the popular mistakes that I see students do is they do 49 minus 12 and then they tag along the root 13, and I'm like, no, my friends, one has a radical, the other one does not, so they're not like radicals, so we cannot combine them. It's kind of like if it was 49 minus 12x, you wouldn't combine them because they both don't have an x. Okay, so just watch out. Okay, for the grand finale, problem E, we have an open bracket, open parenthesis, square root of 5 minus square root of 2, close grouping symbol, plus square root of 3, close grouping symbol, open bracket, open parenthesis, square root of 5 minus square root of 2, close grouping symbol, minus square root of 3, close grouping symbol. Okay, so I'm not gonna lie, this problem is really out of my comfort zone. Okay, the grouping symbol nested inside another grouping symbol is really messing with my flow. Okay, but the intentions are good behind it. The reason why we have grouping symbols nested inside other grouping symbols is kind of to help you to say, look, if you read the problem like this, subtraction plus radical, subtraction minus radical, we have kind of like binomial like expressions. Okay, we will have like a product of conjugates. But again, today I am gonna refrain from multiplication shortcuts, so I'm gonna just do what we gotta do. Okay, first set of grouping symbols, we have a grouping symbol inside the other grouping symbol, so we look at the innermost set. Square root of 5 and square root of 2, they're not like radicals, so we can't combine them. So let's go ahead, clear the grouping symbol. There's nothing to distribute, so we can just drop down the parentheses. Okay, so that will leave us with square root of 5 minus square root of 2. We bring down the rest of the problem, plus square root of 3. Open bracket. Okay, so inside this grouping symbol we have another set of grouping symbols, same speech. Okay, square root of 5 and square root of 2, they're not like terms, so we can't combine them, so we can safely distribute. But there's nothing to distribute, so let's just bring down the terms as is. Square root of 5 minus square root of 2, and then we bring down the rest of the problem. Okay, fantastic. So now we have 3 terms times 3 terms. My mind wants to say, oh, let's FOIL it out. But remember, my friends, FOIL is just a nice way to remind us how to multiply 2 binomials. But in this case, it doesn't really matter whether you say FOIL or not. The multiplication process is the same. To multiply or distribute a 3-term expression, we're just going to have 3 rounds of distribution. Round 1, what do you get when you distribute the square root of 5? Round 2, what do you get when you distribute the negative square root of 2? Round 3, what do you get when you distribute the square root of 3? Okay, we do all our 3 rounds, and then if we have like terms to combine, go for it, and if we don't, then we don't. Okay, square root of 5 times square root of 5, with your permission, we're just going to start multiplying the radicands right now. 5 times 5 is 25, so that will leave us with square root of 25. Okay, next product, square root of 5 times negative square root of 2, positive times negative is negative, and the product of the radicands, namely 5 and 2, will give us 10. So that will give us square root of 10. Final product in that round, square root of 5 times negative square root of 3, positive times negative is negative, and the product of the radicands, namely 5 and 3, will give us 15. So that will leave us with square root of 15. No more terms to distribute to, so round 1 complete. Round 2, what do we get when we distribute the negative square root of 2? Negative square root of 2 times square root of 5. Negative times positive is negative. Product of the radicands, namely 2 and 5, will give us square root of 10. We are trained to write across, but for me, I rather line it up. Okay, so that was square root of 10, and the product is negative. So we have negative square root of 10. Next product in that round. Okay, negative square root of 2 times negative square root of 2, product of the radicands is 4, so that will give us positive square root of 4. I don't have a square root of 4 column, so let's go ahead and do this. Final product in that round, negative square root of 2 times negative square root of 3 will give us positive something. Product of the radicands is 6, so that will give us plus square root of 6. We don't have a square root of 6 column, so let's go ahead and make one up. So 2 rounds down, 1 more to go. For the final round, let's see what we get when we distribute the square root of 3. Square root of 3 times square root of 5 will give us positive square root of 15, and we have a root 15 column. Okay, so let me go ahead, line them up. Again, do you have to line them up? You do not. Okay, you can just do what you're trained to do, which is right across. But for me, it's like, would I rather see a statement with 9 terms, or would I just see a few columns? I would rather go with the columns. It's a personal choice. Let's keep moving forward. Square root of 3 times the next term, product of the radicands is 6, and positive times negative is negative, so that will leave us with negative square root of 6. For the grand finale, square root of 3 times negative square root of 3, product of the radicands will give you 9, and positive times negative is negative, so that's going to leave us with negative square root of 9. We don't have a square root of 9 column, so that's it. So we took care of our 3 rounds, or we took care of our 9 products. Now let's go ahead, simplify, combine as we go, and then evaluate or simplify the radicals that we can. Square root of 25, with your permission, that would just simplify to 5. when we combine the square roots of 10, they do not cancel. -1 minus itself is -2, so that will leave us with -2 square root of 10. Negative square root of 15, positive square root of 15, yeah, these cancel out because their sum is 0. Okay, -1 plus 1 will give us 0. So let's slash them out for dramatic effect. Square root of 4, that simplifies to 2. Okay, I'm going to put a plus sign, okay, because it's not the first term in this expression. Square root of 6 minus square root of 6, well, something minus itself is 0, so they cancel out. And then we have minus square root of 9, which evaluates to 3. So that is our solution. Let's just go ahead and bring this together. Okay, so while we're at it, I'm going to put the like terms, or the like terms next to each other. So we have a 5 followed by a plus 2 followed by a minus 3, and then at the end I'll put the radicals. Okay, if we have to bring stuff down or rewrite it, we might as well rewrite it to our advantage. You know, write down the terms that we're going to combine together and everything else at the end. Sum of 5 and 2 is 7. Someone said, why don't you subtract 3 right now? You know what? I could, but you'd be surprised how many times I do mistakes because I try to juggle more than 2 things. I know myself. If I just work with 2 things at a time, that will minimize the likelihood of me making an arithmetic mistake. Okay, so let's do this. Difference of 7 and 3 is 4. I'm going to box this and then say my speech. Okay, so the question is, are we done? Of course we are, because I boxed it, but the question is, are these like terms? Okay, so they are like terms again because they're both numbers. So with the calculator we can find the decimal approximation, but they are not like radicals because they don't have the same radical part. So there's no way that we can combine by hand. Okay guys, so I said that we were going to do 5 problems. That was our 5th and final problem, so we're out. Thanks.